Today we're going to be talking about square roots and real numbers. And a square root is a number that is multiplied by itself to form a product. So say for example you have the square root of 25. The square root of 25 is 5 because 5 times 5 is 25. The square root of 100 is 10 because 10 times 10 equals 100. Next, we want to talk about perfect squares. A perfect square is a number whose positive square root is a whole number. So, and you can see right off I've got a typo on this. So for instance, 0 and 0 squared, 1 and 1 squared, 4 is 2 squared. So 0, 1, and 4 are all perfect squares. 9 is 3 squared. Do mark out that 4 and put 2 squared there. 16 is the next perfect square because that's 4 squared. All right, 5 squared gives us the next perfect square, which is 25. 6 squared gives us the next one, which is 36. 7 squared gives us 49. 8 squared gives us 64. 9 squared gives us 81. And 10 squared gives us 100. We can keep going forever, but let's stop here. So these numbers that I'm circling, these are your perfect squares. All right? These are a number whose positive square root is a whole number. So we filled in the rest to 100, like it says here. Now let's find each square root. The square root of 49 is 7. Square root of negative square root of 25. I should say, negative square root of 25. The negative's in front of the square root, so we're just going to bring the negative right along, just like we do when the negative's out in front of parentheses. And then we're going to take the square root of 25, which is 5. Again, negative sign is in front of the square root, so just drag it along, then take the square root of 36, which is 6. Square root of 16 is 4. Square root of 4 is 2. The negative square root of 9 means put the negative in front of your answer, and the square root of 9 gives you 3, so we get negative 3. Square root of 25 over 81. We're going to take the square root of both the numerator and the denominator. Square root of 25 is 5. Square root of 81 is 9. So let's move on. As part of her art project, Shonda will need to make a square covered in glitter. Her tube of glitter covers 13 square inches. What is the greatest side length Shonda can have for her square? All right, so first of all, let's move this over a bit. We want to make a square here. All right, so there is her square. And it says that her tube of glitter covers 13 square inches. So we would like to know what's the greatest side length Shonda can have for her square. So the area is 13 square inches. That's your area. Well, we know a square has equal sides, of course. And if we want to find out, and we also know that the way you find the area of a square is you take the side and square it. So in other words, the area of 13 square inches is equal to the side squared, to each for each side being the same. And so if we want to know what each individual side is, if you've got a variable squared equal to a number and you want to know what the variable itself is equal to, just take the square root. The square root of 13 will give you the side. So if we take the square root of 13 and put that into the calculator, put in 13 to hit the square root key, we get approximately, and I say approximately because it's not an exact number, we're going to have to round this here. It's approximately 3.6 inches that each side can have on the square. Okay? Now, we're going to start classifying numbers. We're going to learn different classifications of numbers. So this is just vocabulary you're going to need to memorize. Natural numbers are the counting numbers 1, 2, 3, 4, and so on. Things that you count with. Whole numbers include the natural numbers and 0. You start with 0, 0, 1, 2, 3, 4, and so on. Integers include the whole numbers and their opposites. So -3, -2, -1. All the negative numbers that are whole numbers include 0, and then the positive numbers, 1, 2, 3, 4, and so on. Now, rational numbers are numbers that can be expressed as a fraction. They can be expressed in the form a over b, where a and b are both integers. And remember, b cannot be equal to 0 because, like we talked about in a previous video, you can never divide by 0. Okay? So some examples of rational numbers are right here. Excuse me. Excuse me. We have 1/2, 7 over 1, 9 over 10, anything that can be expressed as a fraction. Okay, you can even have negatives. You can have -2/3 if you want, as long as it can be expressed as a fraction. So let's go on to the next page. Terminating decimals. These are rational numbers in decimal form that have a finite number of digits, like 1.5, like we've got here, 2.75. This ends. Non-terminating decimals, let's add to it. Let's put that right here at the top. I'm going to have to move this. Non-terminating decimals. These are decimals who never end. These have an infinite number of digits. We're probably all thinking of one particular number right now that has an infinite number of digits, and that would be pi. It's 3.14159. It just goes on and on forever. This is the number pi. That's a good example. Obviously, I can't write all of the digits out because it goes on forever. So we've talked about non-terminating decimals. We've talked about terminating decimals. Irrational numbers. Numbers that cannot be expressed in the form a over b. They include square roots of whole numbers that are not perfect square, and non-terminating decimals that do not repeat themselves. So we're, again, another example of an irrational number would be pi, square root of 2, square root of 11. They go on and on. They don't repeat themselves. The symbols that we use for our different types of numbers are as follows. And I know these are a little hard to draw. We have this fancy looking R, which stands for the real numbers. This includes all of the numbers that we've talked about here. So we'll say all numbers we've talked about. Rational numbers. The symbol is a Q, a fancy looking Q. Just do your best when you try to draw these, make these numbers. Make these symbols. Integers are represented by a Z. Whole numbers by a W. Natural numbers are represented with an N. Okay? Let's move on. We want to write all the classifications that apply to each real number. Well, right off, I see that this is expressed as a fraction, even though I can probably, to technically make it look like a rational number, we want to change it to an improper fraction. So we can do that. 9 times 7 is 63, and 4 is 67 over 9. Okay, so we have a rational number which is represented as Q. It also falls under real numbers. All of these numbers we're going to see are real numbers. That's a way you can always classify them. The number -12. Definitely a real number. All our numbers are. It's an integer. And remember, we can also express that as a fraction, say as negative 12 over 1, so that makes it a rational number as well. Square root of 10. Again, always start with a real number. But you know what? This is irrational as well, because if you put that into a calculator, you get some decimal that just goes on and on forever and it doesn't repeat itself. So that makes it irrational. Negative 32, a lot like negative 12. It's a real number. It's an integer. But because we can also express it as a fraction, it's a rational number. By the way, negative 12, negative 32, we can also express those as terminating decimals. I'm not asking you to write that down. Just the other classifications. Whether it's terminating or repeating decimal or non-terminating decimal, you don't have to write that down. 5. That is definitely a real number. It's an integer. It is a whole number. It is a natural number. And it's also a rational number because you can express it as a fraction. Okay, so this takes a little bit of practice. What you have to do is go back and look at your definitions and really memorize those. And we're going to be working on these in class and trying to classify these numbers. So really work on memorizing those definitions. That's what's important. So thank you very much. We'll see you next time.